Well, another Monday is here, and I'm running a little bit late with my video today because I had to go to the tire store and get my buddy down there to break a tire down and fix it. What I have here is a little rundown, sometimes it's not a bad idea, and I found out that years ago that even something that I feel like I pretty well have mastered, or grasped, like something like electrical school, like whenever we would get a new franchise of some kind when I was working at the dealership, the first place they would want to send me was to electrical class. That's just the way it was. And so I says, well, I got to go to another electrical class. So I went to electrical class for Volkswagen, and I went for Ford, and I went for Chrysler, and I went for Jeep. I mean, it's what all these classes. But I will tell you that I never went to a class where I didn't learn something that I didn't know before I went there. And so I have a tendency not to discard the notion of going to a class, even if I feel like I know the subject matter pretty well. One way or another, we're going to get started on this one here. This is the systems. This is basically a little overview of on what does what and why. This was a car that I owned back in the late 70s, a little Type 3 Volkswagen squareback. You might have seen those. They also had a fastback version of that. And the Type 1 was the Bug, the Type 2 was the Bus, and the Type 3 was this one. Then they had the Type 4, which was the 411 to 412, which those were interesting cars because they had a gasoline heater on them that you could turn on before you ever even started the car, and it would run on a timer for about 45 minutes using gas from the tank to heat the inside of the car. One way or another, fuel injection first came out on these cars in 1968. Prior to that, they had two carburetors on them. I used to watch my dad work on these cars at his VW shop, and what he would do is they had thumb wheels down here where you could adjust the carburetors, and you could adjust both the carburetors at the same time while you were listening to it. And he would take a piece of this foil hose like you use for, like what goes from the stove up to your air cleaner on the older trucks. It had a thermostatic air cleaner, and he would listen, because Volkswagen used that from the blower housing going down through the heat exchangers for the heater and all. Well, in one way or another, he'd listen to one carburetor and then the other. I never really knew what he was listening for, but he'd fool with them until they sounded the way he wanted them to sound, and they would run really smooth. Well, this fuel injection that Volkswagen popped on these things in 1968 was a different critter. All right, this is sort of a layout of it. Kind of, if you're interested in the older fuel injection stuff, you had this brain box over here, which I was always really enamored with that. And we're going to look at the other parts a little closer. Get a distributor here, and I'll talk a little bit more about that distributor. It wasn't just a plain old. It did have points for the ignition, but it had some other points in it to trigger the fuel injection part of this. Incidentally, these old they used to say in the schools that these old engine controllers that Bosch was using to start with, you could buy any part that you needed to fix that engine controller from Radio Shack at the time. Everything that was in it was available from Radio Shack. I don't know how true that was, but that's what they always said. And basically, you had this. This gives you if you're familiar with Volkswagen air-cooled engines, you'll be familiar with this because of the way that it was set up. It comes in, it's dual port heads and all that, and so on and so forth. I don't need to look at that slide anymore. The similarities between this here and your the stuff you got now is pretty interesting. You got an auxiliary air regulator. Think idle air control valve. You notice that is pulling filtered air and putting it right in behind the throttle plate, right? So that enables that auxiliary air regulator. When you first started it, it had a little bimetal strip in it, and that little bimetal strip would get power when you first started it. And the bimetal strip, to start with, was letting air go through that auxiliary air regulator, but as that bimetal strip warmed up with its calibrated heat, it would close off a little pintle and it would stop that air. So it gave you your fast idle, right? Okay, so then basically you got your fuel pressure regulator right here, and you got your fuel filter, and you got your fuel pump. As I remember, that was an adjustable fuel pressure regulator. And then you got a cold start injector. You remember I've talked a few times on these videos about how for your cold starts you need to double pulse the injectors, or you have to have a cold start injector that'll put extra fuel in there to wet the manifold, because on a fuel injected engine you don't have an accelerator pump. like you do on a carburetor. There's your ECU. The trigger points on that would basically give you give the ECU what it needed for engine speed, so that it could click, 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 click the injector. You could hear these injectors clicking. They were pretty loud when these things were running. And there was 40 pounds of fuel pressure, and those hoses that they used to feed the fuel pressure to the injectors were those old cloth-covered rubber hoses like the Germans like to use on the older Volkswagens. It's real interesting. And those things had a tendency, whenever they got some miles on them and got old, to start busting, spraying fuel everywhere, or start leaking. But anyway, the temperature sensor and the throttle switch and all that, and your map sensor basically is what this was. They called it something else, but that's basically what it was. It was a map sensor, was an input to the computer along with this, and what it would do is it knew how to expand the pulse width just the right amount based on the engine load. And it was a sort of a funky thing that they did. Didn't have any feedback at all. You basically just had to, the fuel pressure had to be right, and you had to have this thing had to be operating correctly, so it was giving the right information about manifold vacuum and that. And that was pretty much their answer to fuel injection. It came out there early. All right, so change in electronics, the rise of the Vane airflow sensor. The Vane airflow sensor was basically a little air box that had a flapper in it. Whenever the air would come through that flapper would move, and it was connected to a set of points that would slide on this potentiometer. And there was also a little set of points in most of these Vane airflow meters that until that Vane airflow meter started to move, the fuel pump wouldn't get any power at all. When you started spinning it over, that Vane airflow meter had a real weak spring holding that flapper, but it would start to move a little bit, and it would close some points that would operate the fuel pump. If you ever unplug a Vane airflow meter that's set up that way, and you want to start the car with the Vane airflow meter disconnected, you got a jumper, the little terminals that are going to the fuel pump. It basically goes through the Vane airflow meter. You got to jumper those so the fuel pump will run, so you can fire it up without the Vane airflow meter connected. If you disconnect it, you won't get any power to the pump. And these things right here, some of your really early Ford Escort fuel injected engines, like in '83, they had a Vane airflow system. Volkswagens like to use that. Toyota used it all the way up into the '80s, like their MR2 and stuff like that. I priced a Vane airflow meter one time for an MR2 when I was thinking, according to the readings I was getting from that MR2, going by Toyota's book, it looked like the Vane airflow sensor was a problem. But whenever I priced it out and found out it was $800, I decided I needed to look somewhere else before I went and ordered that darn thing. And I found the problem somewhere else, but that's another story. Switches were replaced by sensors, and airflow became the primary modifier. All right, so that's what the inside of that Toyota one looked like. And see the little set of points right here? When this thing starts to turn, that goes that way. In other words, that flapper that you see in here was connected to this, and it was driving it against a very weak spring. And you see this little potentiometer down here? This one right here had a sort of a scorched place, but in spite of that, I made the car run right without replacing this, One way or another, that little set of points right there is what gives you your fuel pump whenever that flapper starts to move. Later, Bosch came out with a different kind of fuel injection that some of you guys are probably familiar with. It's the same kind of fuel injection that was used on the DeLorean. If you've ever worked on a DeLorean, you've seen Bosch K-Jetronic fuel injection. They used it on Volkswagen Rabbits for years. They had these little atomizers with these fat O-rings on them, and you'd snap them down into place where they were going to spray behind the intake valve. And this fuel distributor, as that airflow would be coming in there, and it would go against this plate, and it would raise that plate, and that would raise up this fuel distributor. Now they also had on this, they had a cold start valve right here, but the deal with that was whenever the engine was cold, is a pressure regulator, that when the engine was cold, it would reduce the amount of pressure coming in on top of that piston, so this could raise up farther and provide more fuel. As it warmed up, this pressure would increase, and it would push that piston back down. Now that's an important thing. I'm going to talk a little bit more about that, the way they used that for later for other purposes later. And of course you had an electric pump and an accumulator here and a fuel filter. It's an interesting system. There's your system pressure regulator. See how funky that was. And then they call this an idle stabilizer valve. They did all kinds of stuff. There's those little atomizers that pops in there. And that's what the fuel distributor looked like. There was a little adjustment screw right here that we used to go in there with a Allen wrench. And I think it was a 1/8 Allen wrench of all sizes. I may be wrong about that size. But anyway, we would hook up a exhaust gas analyzer to a little port on the exhaust, and we would turn that screw until we got the CO at 1%, which that was back, you know, in the 70s when we did that, in the real early 80s. But basically, that's how that thing worked, and it had really high fuel pressure. It might have 80, 90 pounds, but see that pressure coming in the top in the middle was what put downward pressure on that piston, and you can actually get all of this stuff in a package if you know where to buy it, you know, to replace the fuel pump and the fuel distributor. If you ever take one of those fuel distributors apart, you'll never get it back together again where it works right or doesn't leak. I'm telling you, those little slots in there that those 4 fuel distributor pistons go past to let fuel go through there must have been cut with lasers or something. I don't know how you can make a slit that thin without it. But anyway, there's your fuel pressure regulator there. And there's a little temperature sensor. This is an oxygen sensor right here. And there's a frequency valve that was actually hooked up in the line between that warm-up regulator and this pressure on the top. And that frequency valve could actually change that pressure. It would frequency valve, if it was working right, you would read it and it would read like 50% if it was adjusted properly so that the oxygen sensor was switching above and below, you know. You might remember on your feedback carburetors how on the GM you'd put the dwell meter on there and you'd look for it to be bouncing back and forth, you know, between whatever it was, 15 and 45. I don't remember those numbers. I mean, I went to school on that and I could dig the book up and give you that information, but who needs that anymore, you know. But the long and the short of it, with these little atomizers right here, nothing special about those. They were basically, when fuel pressure hit them, they just missed it out there. And they just missed it all the time. Whenever this plate was raised up, it would increase the mist. You know, there's your little controller and all. It's kind of interesting. Talking point. Engines may change, but they all need the same element. Engine controls may change, but they all need the same basic information. The engine control module needs to know engine speed, manifold pressure or airflow, and throttle action. Those are the basics. All right, your basic principles don't change. You need a fuel charge on cold start. Older systems use the cold start injector. I showed you that a minute ago. Newer systems simply double pulse the injectors during crank. And a lot of times they'll fire them all at the same time in addition to double pulsing them instead of firing them along by the firing order. The injector pulses must match the speed of the engine after the engine starts, except for those extra little shots between pulses that happen with throttle movement, which mimics the operation of an accelerator pump. Ignition timing must advance with engine speed unless the engine is loaded. If the engine is loaded, the timing will go back close to base so it doesn't ping. But whenever the ignition timing, if you're just giving it the gas and it's floating, you're going to have like on this other question on the test I put out there last time. If you're driving down the road just holding your speed like 50 miles an hour or something like that, you're going to have the ignition timing up around 45, 55 degrees, something like that. That's why it's important to have the rotor line proper. Now, fuel supply's got to be more than adequate. There's got to be more fuel than it needs coming to that thing. So if it's running low on fuel because the pump is weak or whatever, you're going to have some power loss, and that's never a good thing. On this one here, this little diagram here has got your fuel filter, and then there's your return flow. Now, I don't talk a lot about diesels on here, but on those diesels, one of the things that they discovered, and Volkswagen had problems with it too, if you run that return back so that in a diesel, I'm not talking about a gas burner, I'm talking about a diesel, if it's spraying out above the fuel in the tank in a mist so that it's above the fuel, that stuff will get oxidized and turn into tar. You might have seen that tar that clogs up some of the fuel screens. And on the later models, when they finally figured that out, they would run the return all the way to the bottom of the tank, and they'd run it out through this little duckbill thing so that it sprayed out underneath the fuel and it didn't mist out into the air above the fuel and turn into tar. That's for diesel now, not gas burner. All right, now the returnless fuel system got rid of the return. The fuel pressure regulator would either be here or it will be down in here built onto the pump, like it is on some of your Cadillacs that we've seen, like their Alt Series Cadillacs. There was this Cadillac, and I don't remember if I ever told this story on here or not, but this lady come in here on her Cadillac and she said, I've got a traction control light on my Escalade. And I said, well, right now at the time we weren't doing any of that kind of work, brakes or electronics or anything. And I says, go ahead and take it over to Randy at the Cadillac store in Dothan and see what he's going to say about, what maybe a reflash or something like that. I didn't even get into it. I mean, we pulled a code for traction control. So she took this '07 Cadillac Escalade over to the Cadillac dealer, and she came back and she told me the Cadillac dealer said I needed a fuel pump for this traction control problem. I said, what in the world were they talking about? She said they said the fuel pressure was too high and they needed to replace the fuel pump. And until they replaced the fuel pump, they couldn't do anything else. But they wanted $1,800 to put a fuel pump on it. And I said, well, let's see what we can do here. I know, check the fuel pressure. The fuel pressure was 160 pounds. The regulator that was built onto the pump inside the tank had failed, and it was letting the pressure just go. But the vehicle ran just fine. All she had was a network code, as I remember, and a traction control light and all that. So we got a $450 fuel pump from the parts store. We popped that in there. Fuel pressure came back down to where it was supposed to be, which, as I remember, was maybe 60 pounds or something like that. So after that, her traction control light and her network code were gone. Now, I don't know what the deal was there, but I do know that they knew what they were talking about because they'd seen it before. If you got failed fuel pump, too high fuel pressure, throws the network code and traction control. I like to try to reason this stuff out, and something like that just drives me up the wall. The car was fixed and she was happy, but just really weird. Of course, weird stuff happened with her car anyway. She had two vehicles. One was an '07, one was an '08. The '08 was a white Nissan Titan or something, pickup truck. And she had this black Escalade. All right, we put her a set of brake pads and machined the rotors on her Titan, and everything was fine on that. We did the same exact job with the same brand of brake pads and did the rotors and all that on her Cadillac. She came back about 3 weeks later and she said, I've got brake dust all over the side of my black Escalade here, and you could run your hand down and it's just coated with brake dust. It's the strangest thing I'd ever seen. We cleaned all that up and put her a different set of brake pads on there, and all that brake dust was gone. This was on both sides. I don't know if that particular set of brake pads was faulty or what the deal was, but it was one of them things. Anyway, I got off on a tangent. But anyway, the fuel pressure regulator will either be just outside the tank, like on some of your Chryslers, or it'll be down inside the tank on these. Now, there is another way of doing that too. You can actually use a sensor on the fuel rail. You can use the PCM. You can use a module. And that module will change the amperage going to the fuel pump. There's this one guy I knew about that had a Mustang that was running really, really rich. And the fuel pressure was all screwed up, and he found out that inside the fuel tank somebody had put a fuel pump in it, and the wire that delivers the ground from the module of the fuel pump had shorted to the bracket on the pump or something, and it was giving full power to the pump all the time, and the pressure was completely off the charts. I have talked about whenever you're going to check and see if the fuel pump has got good continuity all the way through, you can put a test light in there and see if it lights up. You can't do that when you got a fuel pump module unless you do it right back there at the module. Also, there are these three-phase DC electric fuel pumps that some vehicles are using now they're DC fuel pumps, but they basically got some electronic circuitry driving them, and it's like the motors that drive the transaxle on the hybrid vehicles are three-phase AC, while the three-phase DC motors are also used in electric power steering, but they've started having some fuel pumps that are three-phase DC as well. So be aware of that. They're not all plain old DC brushed fuel pumps. Brushless pumps are three-phase DC, and they basically on a a brushless electric motor, you know how on a regular permanent magnet motor, the magnets are around the outside and the part in the middle is fed by the brushes, and that causes your magnetic field to make the motor spin. Well, on a brushless motor, the magnets are built onto the spinning part, and the windings around the outside are delivered with pulses from the electronics, and there's, you know, little feedback mechanisms and all that, depending on who built the motor and how it's built. Anyway, the motor runs without brushes entirely, and it's usually a slightly better setup because brushes tend to wear out and stuff like that, you know. Now, Chevy CSFI systems have the fuel injectors in the spider center with poppets that react to bursts of pressure, 60 psi or so, to spray the fuel in the intake. Those poppets will not operate on some of those. It's a little bit of a fruit basket turnover because of product variability, but if you've got the plain old poppets, they got a little solenoid in here that lets little bursts of pressure go to those poppets. And if the pressure is not high enough, you may have 55 pounds of fuel pressure and that vehicle still not start because the poppets won't operate with not enough pressure. And it's you know, you need to make sure if you've got a CSFI that won't start, if you don't have at least 60 pounds of fuel pressure, you better be doing something about that. Of course, it's a sliding scale. And one of these per cylinder is what it's got. That's that little solenoid with 2 pins on it, and that poppet goes down in there. Well, what it looks like when it's on the vehicle, when you've pulled the plastic intake off, it looks like that right there. This right here is where your EGR comes in, by the way. And so the replacement spider with electronic injectors instead of poppets is what I put on my dad's pickup truck. Those things right there, they sell them at the Chevrolet place, they sell them at the parts store, they cost $300 or $400. But if you got one of these kind of vehicles, when you put that on there and you put it back together, you can't tell it's not factory, and it works better than it's not as pressure sensitive and all that as the older ones were. I like this setup here, and it's not that there's your fuel pressure regulator set up the same way, and you got your the injectors are basically, you know, their little solenoids are right there on the injector instead of being up in here delivering bursts of fuel pressure. They work like a dream. We put several of them on. Alright, CSFI stuff, they've got a crank sensor in the timing cover and a cam sync sensor in the distributor. The cam retard offset has to be checked if problems arise or if the distributor's been removed and reinstalled. With the engine above 1,000 RPM, the distributor is rotated if it can be. Some are fixed until the CRO is on 0. Cam retard offset's got to be on 0. That's most of the time where those set at. A lot of the times, if you've got one of these engines that's running really crappy, I usually just throw a distributor in it anyway because it's got a new sensor. But when you put that new distributor in there, you better set that cam retard offset, because if that cam retard offset is off enough, it will bank fire the injectors and your fuel economy will go to the toilet. If it was getting good fuel economy before and you pull that distributor out and put it back in, even if it was running fine before and you're just fixing an oil leak, if you don't set that cam retard offset, you're going to have fuel economy issues with those CSFI Chevy deals. Because you don't want it bank firing the injectors when it's supposed to be firing them sequentially, and that's what it'll do if it can't trust this signal. Now, I will tell you that cam retard offset signal makes its cut at 24 degrees after top dead center, because that's when all the fire has gone out in the cylinder after the spark plug fires. The Ford makes its cut at 24 degrees after top dead center, just like this one does. That's a magic number apparently on these engines right here, which would be your gasoline. Whenever the explosion happens, it's just slapping the head of the piston. On your diesel, because of the way it fires and it burns slower, it's pushing the piston all the way down. That's why diesels have got such good torque. Alright, the cam retard PID should be accessed. The engine speed should be above 1,000 RPM when you're setting the cam retard offset, because the cam retard offset is inaccurate below 1,000 RPM. That ought to be turned until the cam retard offset reads 0. On some 96 models, it'll be 8 to 16 degrees and minus 5 to 17 on 97 models, but typically 0 is the number that I have used on most of the ones I've worked on, including the later models. You know, GM still use this all the way up past 2000 on some of their 4.3 packages and pickups. Unless you hacksaw the ears off of the distributor so you can turn it, you may have issues with that. A lot of the times, you know, the right way to go is to get rid of that ridiculous plastic distributor and put an aluminum one in there. Those plastic distributors I've always thought were kind of a joke anyway. I mean, they work, but the aluminum when they sell it at the parts house to replace this plastic one is so much better. And also you might remember these right here. You got to pay attention to where you're putting the plug wires onto these because of the way they're designed. All right, Dodges and trucks and Jeeps. Now, Dodge trucks, a lot of them have a setting sort of like the camera tart offset on those where you pull it up on a scan tool and you're supposed to dial it in. And this, you're not changing the timing when you turn the distributor on these, okay? Just be aware of that. I'll talk about that a little bit more in just a minute. But whenever you turn the distributor on the one that's got a cam sensor in it, all you're doing is changing rotor alignment, and you're also changing the relationship between the cam sensor. You're going to get a different signal going to your computer on that. I used a piece of wire here, but on the Jeeps, you put it on top dead center compression 0. You turn this around to where it's lined up, where you can go through the hole in the side of this housing and through that. You can line that up. That's a 4-liter straight 6 Jeep. On the Dodge, you use a scan tool and you adjust it. I think it's to 5 degrees. Don't quote me on that. You may have to look that up. But you use a scan tool to set it on those too. Typically, if it has a crank sensor, you don't turn the distributor, adjust the ignition timing, except, and I think I mentioned that later here, in a 2001 and that vintage Xterra, they have a crank sensor, but the only thing that crank sensor does is it gives it information so it can check for misfires. It does not provide, you can unplug the crank sensor on an old Xterra like that, and it still runs because everything it needs for the ignition is in the distributor. And you also have to adjust the timing on one of those, even though it has a crank sensor. Just about everything else doesn't. Now, the V8 engines like these have on them, when you put that crank sensor in there, you don't just slide it down in there and buckle it up. It's got a slot that's adjustable. You can buy these spacers from an aftermarket supplier. I bought a box of them. Can't remember who makes them. But anyway, maybe Standard Ignition or something. Anyway, you stick a spacer on the bottom of that crank sensor, a little cardboard spacer. You slide it down so it's touching the crank wheel on a tooth there, and then you tighten it up. That sets the gap. If you don't put that thing in there with the right gap, it won't run right. Found that out the hard way. But when that gap is right, that thing will run really smooth. But when you're putting the crank sensor in, if you get a new crank sensor, it'll come with that little spacer on it. Skins it off when you start it, and then the gap is set right. All right, on this one here, if you're going to set it with a scope on the Jeep 4-liter, you dial it in so it's halfway between this. This is crank, that's the cam sensor. And that's a 50% duty cycle right there. And all right, on the turning the distributor doesn't change the timing if it has a crank sensor. First time I ever ran into this was in 1983 when I was working on an old EEC 3 Ford that had a crank sensor with those 4 spikes on the balancer, and that crank sensor going down there. It had a blue wire and a gray wire going down there to it, and you had to set the rotor alignment on those with a special little tool. Somebody that's worked on those might know what I'm talking about there. On your out of alignment rotor, if that's pointing too far one way or another, whenever the timing advances to 50 degrees when you're cruising, it'll jump and hit the different post, and you'll feel it as a surge at road speed, okay? Really important. All right. Quick test. What's EGR and why is it necessary? Well, EGR doesn't flow at idle, doesn't flow at wide open throttle, doesn't flow on a cold engine, cools the combustion chamber to reduce NOx. On some of your diesels that have EGR, if you open the EGR when it's idling, it quietens it down. All right, what's PCV? Why is it necessary? PCV, you see how the valve works there. Pause the slide if you want to. It's basically purging the vapors out of the crankcase that are blow-by from the pistons. Right, there it is. All right, some PCV systems don't have a valve. They just basically have a little orifice back there like on this 4-liter Jeep. All right, what's evap and why is it necessary? Non-enhanced measures only evaporative system flow. Enhanced system can seal the canister vent and measure tank integrity. Natural vacuum leak detection measures how well it holds the pressure after the engine is turned off. And Chrysler systems use a leak detection pump. That is pretty well all I got time to tell you about today. and I'm going to upload this video, and I really appreciate you guys watching. Hope you got something out of this that you can use. I know I talked about some older stuff, but you know, a little bit never hurts. See you later.